So just to give you an idea, that was with these values right here, just starting off. Here's the set point, right? So let me just expand this a bit. So you can see that here's the response. It overshoots, starts to come back down, and then changes, right? So in other words, this was the argument there was 0.785, so that's 45 degrees. So it's supposed to go to 45 degrees, and then this is like about 0.8 of a second here, and then and then it drops back down. And this sampling for this simulation is also set at 100 hertz, which is what you're going to do your actual physical arm with. But you can see that here's where the actual arm goes, overshoots, and so on. And you know, so now you can, if you want that to shoot up faster, right, and I'll just run that again, and you can see, so now it's actually overshooting even more because I made the case of P larger. All right, so it's responding faster. And anyways, there's this allows you to run this simulation and see what, try to dial in the values for the gains. And remember from the lecture slides, we had these two different suggestions here for the manual tuning. So here's one procedure you can follow. The Ziegler-Nichols method, you can try and apply that. You can talk to the SAs and see what casual tuning technique they think will work. But anyway, so you're going to do some casual tuning and play with these case of P, case of I, case of D in that in this simulation here, and then just go ahead and run it. So, but you don't have to really write any MATLAB code to do that. So the other thing you can do is you have a zip file for the Arduino PID, and there's a Python. You can there's some instructions on how to set that up if you want to set that up on your own computer. You don't have to do that. It should already be, write some instructions here. It should be all set on the lab. You can just ask an SA or TA if you're having any trouble with that. So the idea with the Python, this plot.py, it helps you in real time, you know, take you have the serial right out to the monitor, but instead of just looking at numbers, you can actually plot some stuff. Okay, so here's an example of a screenshot from that Python package, right? So in this case, it's going from 0 to 90 degrees, right? The green is the set, and the blue is the actual, and you can say this is dialed in really good. I'm not going to scroll down and show you what the gains are because obviously I want you to try and figure out the gains on your own, but you can see that this responds pretty well, and this is oscillating back and forth, or this step is about a second long, right? So it stays a second at 90 degrees, then a second at 0 degrees, and so on. And again, your sampling rate, right, sampling rate is 100 hertz. So right, so you'll sample at 100 hertz. A good way to do that consistently is just use an interrupt, and then you'll output the current position, desired position, PID output, and the PID gain values, and use that Python program to be able to generate that graph. So, and then of course you can compare your simulation results to your physical system and see how that works. Excuse me. And then finally, you'll be also completing a state machine diagram as part of this lab. And that doesn't have to be in the lab report, but Brad Miller will be doing a lecture on that on Monday to explain how to do that. So anyways, I think you're all set for lab 4.